one equation. Don't show them two equations. They'll fall asleep. But I just want to show one equation, and that's a very simple equation on the greenhouse gas intensity from the Australian electricity network. This could be any country's electricity network, but let's just think about us for the moment. So kilograms of CO2, the mass of CO2, I'll forget about other greenhouse gases for the moment. Let's think just about CO2. The kilograms of CO2 per kilowatt hour of electricity produced. That subscript E means electricity. We can just express that in terms of three independent terms. The first is the average fossil fuel intensity. That is the kilograms of CO2 you get by just burning some fossil fuel, coal or natural gas. Then times the one on the average efficiency of the plants that do that burning, times another term which I call the measure of renewable penetration. So the stuff that doesn't emit CO2. Okay? Now I've been simplistic here. I haven't, in many ways, I'll mention that in a moment. Now the measure of the renewable penetration is just 1 on 1 plus the renewable energy that we produce divided by the fossil energy that we produce. So the first question is what are we currently doing? You get a surprisingly accurate number, as I show in a moment. If you go to the Department of Climate Change and Energy Efficiency, they say it depends how you look at it, but we're about 1 kilogram per kilowatt hour of electricity produced at the moment, depending on whether you take it at source or at the end user. The next question is if this is about the future in coal and gas, if you've got a simple equation like that, let's be techno-optimists, as many people are, and let's see what we think reasonably this stuff could do and see whether we can get to the goals that the federal government has now set for us, which is an 80% reduction in CO2 equivalent emissions in 2050 against 2000 levels. So, here's some simple results. First thing I want to do, in the spirit of my techno-optimism, is say let's assume that we're not going to consume any more electricity in 2050 than we are today. And there's actually some justification for that, and you see it earlier in the CO2 emissions from today in electricity relative to 2008. It's dropping. In fact, our national electricity consumption is dropping, and unfortunately for the generators, so is the wholesale electricity price. So let's just, but if there is significant growth, the target of course gets harder because we're generating more electricity, so per kilowatt hour of electricity it gets tougher. So let's go, okay, we need to get to point 2, that's the aim. But at the moment, if I take the current system, mainly coal, a bit of gas, about 9% renewables, PV, hydro and biomass sources primarily, sorry, wind, hydro and biomass sources primarily, we get, in my simple equation, 1.01 kilograms of CO2 per kilowatt hour. And that was just me going, oh, average thermal plant, if it's brown coal 30%, if it's black coal it's 35%, if it's a gas turbine it's 35%. That's the number you get. And I thought, oh, that's all right, not too bad. Now let's look at some simple cases. Here, let's turn off every power station we have in the country and replace it with the most efficient black coal power station currently in existence, which is in Denmark. An ultra supercritical black coal-fired power station with a reported electrical efficiency of 49%. Well, if you do that, you get to 0.82 kilograms per kilowatt hour electricity, well short of our 0.2. Similarly, let's take then the most efficient brown coal power station in the world, in Germany, 45% reported, you get 0.89. Further away, we won't go into the reasons why. Let's take the world's most efficient combined cycle natural gas power stations, which are now made by Siemens and Mitsubishi Heavy Industries and General Electric. They have all reported 60% thermal efficiencies. If you plug that number in, what do you get? 0.3. Not bad, not too far away from the 0.2 that we need to get to by 2050. All right, so let's now think of some simple optimistic combinations. And there are, of course, an infinite number of these. Of course, the renewables at the bottom there is 0, ideally. But let's go. Exploiting that low, very low, 0 emissions intensity of renewables in this idealised case, Let's now think of some simple combinations that get us close to this 0.2 number. So 75% renewables and 25% black coal can get us to 0.21 on this simple analysis. Now, implicit in that is that we can deal with this deep penetration renewables by handling their intermittency, most likely through cost-effective energy storage, for example. Or if we go with combined cycle and use its much lower emissions intensity, we can go to 40% renewables and 60% combined cycle, and we're down at around 0.2 again. Or we have another scenario here where we can have 50% renewables and some black coal and some natural gas. But no matter which way you cut it, if you don't have carbon capture and storage, CCS, you cannot get anywhere near 0.2 from coal in particular, okay? That's just the way it is. So it's a scenario where I'm assuming no growth in energy consumption. Now, I can't remember the exact numbers. I think about 75% of our electricity comes from coal, about 15% from gas. We're going to go from 75% of the coal that we currently burn to much, much less than that. We have to meet this federal government target. Now, to put some things in perspective, though, we've talked about ourselves a lot here, but this is what the IEA says is going to be happening in 2035 if the new policies scenario, which is if all governments enacted all policies that they had in place to their full efficacy as of 2011, this is what we're likely to see. So those circles are the size of the absolute emissions, and the triangles are the relative increase to 2011. Sorry, 2010. So you can see Australia in this new policy scenario has reduced our CO2 emissions by 16%, United States 15%, European Union 22%, but India, China and the Middle East and Russia in particular have significantly grown their global emissions. And we go back now to this chart showing that coal is becoming king again and our economic link to that massive growth in China. So I want to leave it there, but first I want to go back to some specific questions. The three questions that I asked at the start of the talk. I want to add some more specific questions. First, what is the scale of the CCS challenge and when will CCS be deployed? How are our local coal mining and upstream gas industries, the people who take it out of the ground and take it to the terminal, for example, or the refinery or the LNG plant, the upstream gas industries, supporting the downstream industry in implementing CCS, the people who will use those fuels to make electricity or other products and then put the CCS, the captured carbon under the ground. I'd also think we could discuss what are the measured, not the inferred or estimated, levels of fugitive emissions and wastewater from coal and gas. That's attracted a lot of discussion in the last 12 months in particular. And another question which is perhaps less obvious to many of you is how can any new baseload plant be justified in the NEM? The spot price, average spot price last year for electricity in the wholesale market is less than 3 cents a kilowatt hour. That is less than the cost of building any baseload power station of any form if you take that cost over the whole plant life. And then I want to ask some questions also, perhaps to the audience. If we want to decarbonise, first question is what kinds of energy does the world want? And what does this mean for the future in coal and gas? Let's base this on the data, not on what we want to happen. And the second question is are there significant alternative exports for Australia? And with that, I'll hand over to our two guests.
Okay, well, I think if we would even try and answer all those questions, we'd be here a lot later than 8 o'clock, even if we gave Nikki and David no time. So I think Michael's certainly throwing out a challenge in terms of how people might want to explore some of the issues that he's raised in that short introduction to the topic. Now I just ask, as I said before, ask our two representatives from the industries that are impacted most directly in respect of some of these challenges, namely the coal and gas industries, to give their responses and some of the things they might like to add to this before we get stuck into it. And which the first of these is, as I said, Nikki Williams, who's currently the Chief Executive of the Australian Coal Association. Thanks, Nikki.
Good evening, ladies and gentlemen. I guess, in case there's any doubt, the coal industry absolutely agrees with Michael's view that, and probably not a very bold opening statement, that we obviously have to significantly reduce our greenhouse gas emissions globally. It's also very clear that emissions reduction presents a very major technical, commercial and political challenge. Am I supposed to drop down? No. I want to get to the technical and the commercial issues in a moment, but I also think that the domestic politics of this issue probably require some comment. The public policy debate on energy over the last few years has had a number of very striking dimensions. It's been politically divisive, first claiming the life of the Rudd government's carbon pollution reduction scheme, then ejecting Malcolm Turnbull from the Liberal leadership, before contributing, at least in part, to the demise of Prime Minister Rudd himself. Now it's holding the current government somewhat hostage, and whether that's because of a perceived breach of faith, whether perhaps it's failed to sell its reform effectively, or certainly from my own industry's point of view, the genuine concerns that exist with very fundamental flaws in the scheme. The carbon tax is like an albatross around the government's neck. Now, the debate has often assumed histrionic proportions, like calls for the Australian coal industry, which is a flea in the global scheme of things, and although a very significant part of the Australian economy, it represents just 1.6% of the world's coal production. Notwithstanding our relative size, of course, there have been calls for our industry to be closed down. Of course, the industry has also been described as the great demon of civilisation. Apparently, mining is also stealthily undermining Australian food security. And of course, there's a very common theme that gas alone is the answer to our climate change prayers. Suffice to say, I think that the quality of political debate on climate change has been a huge inhibitor to progress. It has contributed to a very low standard of energy literacy amongst the Australian community. And it's why forums like this, although a relatively small audience compared to the total Australian population, are so important, so that we can actually have a discussion around many of the factual dimensions of what is really quite a complex policy area. The Australian coal industry itself has a very strategic interest in the research and the development of climate change solutions through what's known as ACOLET, the Australian Coal Association Low Emission Technology Fund, and I'm also the CEO of that organisation. The work of ACOLET in investing the industry's Coal 21 fund towards accelerated demonstration and deployment of carbon capture and storage technologies underpins our industry's social licence to operate in Australia, and it forms a very important part of our contribution to the global development of low-emission coal technologies. And it sets an example in Australia and, I think, to the rest of the world. Indeed, it's one of our competitive advantages. My Deputy CEO has just returned from a trip around Europe where he's been visiting major CCS projects in Holland, in the United Kingdom and elsewhere. And he has spoken to me about the enormous interest from proponents and those scientists and others who are involved in carbon capture and storage projects around the world in the Coal 21 Fund. It is a world first. There is no other coal industry in the world that has sought to take a leadership position in terms of contributing to the development